Hi, so today we are looking at section 1.4 in your books. That's subsets of lines and planes. So we're looking at lines, components of lines, and also components of planes. So there is a lot of vocabulary today. I do recommend that you have your notebook or that you're printing these slides out or something like that just so you have notes, okay, because there is a lot of vocab here. So let's get started with the basic lines, okay? The first one that we're looking at is a half line. So whenever you see this word subset, I want you to think of part of, okay? Whenever you see subset, that means a part of. So a half line is a part of a line consisting of all of the points on a given side of a point of a line. So I know that looks that looks kind of crazy, and it's denoted AB. And if you notice that this line right on top right here, it has that open circle because it does not include the point A, and it is pointing toward the direction of B. So I'm going to try to draw this the best that I can. Okay, so that's my line. Here is point A. Really, this should be an open circle. I'm going to open that up. So that's point A. It does not include A. And here's B. And there's my arrow. Okay, that's what the line looks like. And that AB is the name of the line. A ray is your half line, and it includes the origin. Okay, so when it has that union, it means it includes, and it's denoted AB with the arrow on top. Now notice this arrow does not have an open circle because it does include A. So here is my closed circle A and my closed circle for B. Okay, we're going to pretend like that's a decent A. So whenever you are naming a half line or array, it is important that the origin is named first. The circle, whether open or closed, that needs to be named first. The second letter is the direction that the line is going towards. Kind of like a rocket ship, I guess. You know, it's going in one direction. Okay, we have two postulates, if I remember correctly, two postulates in this section. So the first postulate is the line separation postulate. So every point on a line divides the line into three disjoint sets. Okay, that means that these sets are not connected. It includes the point and two half lines. Okay, so I'm going to show you that the first one, okay, we're going to pretend that is a bracket. This is A. There's my point. And so that separates this line into two sections. One section is this half line that we're going to call AB. And I'm going to use the symbol to indicate that it is a half line. Okay, so the other half line I'm going to draw for you, but I want to give you a minute to think about what it's called. What do you think this half line is called? So I know I'm going to need the symbol because I already said it's a half line. The origin is at A, so that gets to stay the same. And then in what direction is it pointing to? Which other point is it pointing to? Hopefully you are thinking it is D. Okay, moving on to the next slide. So this is the definition for between, and I know it sounds silly to have a definition for this, but in geometry they're very particular about how words are used and how we use them to prove things. Okay, so point P is between R and S, and we can see that right here. It is denoted as RPS, so notice it's the order that it's in, and they are collinear. So, whoops, these are supposed to have arrows on top. I forgot to add those. but the intersection of PR, so I'm going to go ahead and make my arrow. There's PR and PS. There we go. So I have my two rays, and their intersection is point P, because that's in between R and S. The next definition that we're looking at is opposite rays. So PR, which we kind of drew before, and PS are opposite rays. And that's only if P is between R and S. If P is not between them, then they are not opposite. A segment consists of 2 points and all of the points between them. So it doesn't go on infinitely. It's not a line. It's a segment. It starts and it ends. Okay, and this is you do not have to write this down right here. Especially if you don't understand what it means, but it basically means that the segment RS consists of these two elements, R and S, in union with X, such that X is between R and S. Okay, so it starts here and it ends here. Okay, and the way that we denote this is just the line on top. There are no arrows. It starts and it finishes. So here's our first example. It says determine whether each statement is true or false. So I recommend drawing this out as much as possible. Okay, doing this in your head will not work out in your favor. So please draw it out. The first one is a ray, CD. So I'm going to start at C. It is a closed circle. And I'm going to draw a line in the direction of D. The next line or subset of a line that I'm looking at is CA, and I can see that there's an open circle because it is a ray. So I have an open circle starting at C, and then I'm going to go in the direction of A. So now that I've drawn that out, I really want to pay attention to what this is asking me. It's asking if my ray intersects the half line. Wow, blank there for a minute. So this is the sign for intersect, as in what do they have in common? Right here it's giving you a statement, so it's saying what they have in common is C. But take a look at these two lines. Do they really both have C? This one does, but this one does not. There's a hole where C is supposed to be. So the intersection is null. Okay, there is no intersection. Okay, here's our next statement. We have CD, so I'm going to draw that. It is a ray. And it also has CA, a half line. So similar drawing. But this time they're asking something else. They don't want to know what they have in common. It's saying if you put these together, okay, this is your union. Okay, my sloppy union, okay. So if you put these two lines together, are you going to get a giant line that you can call AE? Are all points accounted for? Well, A is accounted for, B is accounted for, and everything in between. C is accounted for, D is accounted for, and E is accounted for. So all of the points are accounted for, which means that this is true. It's a true statement. So this point right here filled in the gap from the other half line. Okay, this is our last statement for this example. We have BC, which is going to start here, closed circle, go in the direction of C, and then ED, closed, go in this direction. Okay, does that equal the segment EB? So segment means that it has a start and an ending, right? And this is the intersection. So what do they have in common? So I'm going to go ahead and say that they have all of this in common. And I'm going to shade that in a different color. Okay, so they have all of these points in common. Does that make the segment EB? Let's see, we can say our segment starts here, right, at E, and it does end at B. So it looks like that this statement is true. So if you need more time writing any of this down, you can pause this at any time and take your time to write notes as you need them. So this is the second postulate that we have that's very similar to the line separation postulate. This one is the plane separation postulate. So every line in a plane divides the plane into 3 disjoint sets: the line and 2 half planes. So here is my line P, and I have a half plane here that's called H1. And then I have a plane here that's called H2. And we're going to use the same diagram for the other definition. So feel free to just draw it one time. You don't have to write these definitions word for word. I tend to draw a picture and just label it. So the half plane, which was kind of given to you in the previous example, is that part, okay, the subset of the plane that has all the points on the given side of the line. So here's my half plane that I shaded. Okay, it is half of a plane. It's not rocket science. The half plane's edge is the name that we call that line that separates the plane into the 2 half planes. So this line right here down the middle is the edge. On the opposite side of each edge, okay, we have the 2 planes, the 2 half planes, and because they share that common edge, they are called opposite half planes, okay? So H1 is one and H2 is the other, okay? Opposite half planes share that common edge, and that's what separated them to begin with. An angle. So this is something that is probably very familiar to you already from middle school, but an angle is the union of 2 rays with a common endpoint. So we have ray BA, and then we have ray BC. So they share a common endpoint right here. And we'll get to that definition in just a moment. But that is the definition for an angle. The sides of the angle are those rays, okay? When they say, okay, this is the side or adjacent side, we're going to see all sorts of sides for angles, but it's formed by the 2 rays. So the sides of these angles are called ray BA and ray BC. The vertex, okay? The vertex is the pointy part of the angle. It is the origin of each of those rays. So the name of this vertex is B, right here. The interior of the angle. So interior we know is just another word for like the inside. Okay, so that's the intersection of the 2 half planes determined by the sides of the angle and the points containing, and containing points from the other side of the angle. Okay, so all of this shaded part right here, all that purple, now turning to green, that is the interior of the angle. It's the inside. The exterior is going to be the opposite, right? It's like the complement. It is not the interior. So anything out here, outside of the angle is called the exterior of your angle. So there are a few different ways we can call angles, okay? So I have the 4 different ways here. We can call this angle ABC, and we do that by following A, B, C. We could also call this angle the opposite way. We can start at C, CBA. We can also call this angle by its vertex. In this case, it's a B. However, we can only call it by its vertex when it's not sharing that vertex with any other angle. So thankfully, this is only one angle, so we can call it by its vertex and say, this is angle B. And if you notice on the interior of the angle, we have this number 1, and so you could also call this angle 1. So if you decide to use the points like the A and the B and the C, please be sure to use the vertex in the middle. Okay, the vertex should always be in the middle of those 3 letters. So we're going to practice naming some angles in just a moment, and after that you have your classwork. So this is available on Microsoft Teams. If you have any questions or need help with anything, please reach out to me. I'll help you in any way that I can, okay? But in the meantime, let's practice. Okay, angle YWZ. We're looking for other acceptable names to name each of those angles. But first I need to identify where is YWZ. So I'm going to just follow the letters. That's the best way to do this. So here's Y. I'm going to go down to W and then go up to Z. Okay, now that I see my angle, I can see different ways to call this. So one of the easier ways to do this is just, what is it backwards? I can say it's Z, W, Y. I could also call it angle 2. And I think that's it. We can't call it angle W because that vertex is the vertex of 2 other angles. So we can't do that. Okay, let's look at angle 1. So angle 1 is right here. What's another name I could call angle 1? Okay, I can call it XYZ, or I can call it the opposite, which is YWX. I may have said that first letters wrong. I don't even remember what I said, but I may have said that wrong, so just bear with me. That's pretty much the only other thing that you can call it, just the 2 XWY and YWX. So let's look at this third angle. The third angle I'm going to make green, so I'm going to follow the letters Z, W, X. Okay, so that's my big mama angle right here. And no, you cannot call this angle angle 3. Okay, it's not labeled as 3, so I can't make up labels for this. So the only other name that you can call this is its name backwards. So X, W, Z. All right, so that's it for today's lesson. Again, please be sure to check on Teams under lesson plans for your corresponding homework assignment.